in this video, we are going to see one problem on narrow band pass filter. So the question is, design a multiple feedback narrow band pass filter with resonant frequency FR is equal to 1 kilohertz and Q value is equal to 3 and AF, the gain is 10. Okay. So though for the narrow band pass filter, Q value must be greater than 10 value. So the question is given like this. Okay. So you know how the band pass filter will look like. This is how the band pass filter will look like, and this value is nothing but FR, and Q is nothing but FR divided by bandwidth. So if you know the formula, you can solve this problem. If you don't know the formula, means you have to derive the equations, right? So they have told it is this is nothing but multiple feedback. So I can construct the band pass filter like this. Okay. So let me take this is V0, and so you must have a multiple feedback, right? So let me take this is R3, R1, and this is sorry, and this one is 1 divided by SC, and this is also 1 divided by SC. Okay, where C1 and C2 is equal to C. Okay, so you have a multiple feedback, right, from the input, from the output. So you have one feedback and another feedback. So let me take this current value as this one as I3. Okay, the current flowing through this one, and this one as I2, and this one as I1, and this one as I4, and this one as I5. Okay. So if you see, if I apply the KCL at this point, so this point is nothing but 0, and this is nothing but VA, right? So at this point, applying the KCL, if I apply KCL, I can write I3 value is equal to I5, right? So the I3 current is equal to I5. So this I3 current, I can write it as V by R, right? So VA minus 0 divided by 1 divided by SC is equal to VA minus 0 divided by 1 divided by SC is equal to 0 minus V0. 0 minus V0 divided by R2. Okay. So on solving, I will get V0 SC is equal to minus V0 divided by R2. So from this, I can write VA is equal to minus V0 divided by SC R2. Okay. So applying the KCL at this node, okay, at VA. So I can write I2 current is equal to I4 plus I2 plus I3, right? So I1 current is flowing, this is incoming current, the outgoing current is I4, I3 and I2. So I2 current, I can write it as V in minus VA divided by R1, that is equal to I4 current is VA minus V0 divided by 1 divided by SC, plus I2 current is VA divided by R3, and I3 current is VA minus 0 divided by 1 divided by SC. Okay. So this I can write it as V in divided by R1, that is equal to, okay. So if I take V0 common, I will get like this, plus if I take V0 common, I will get SC plus 1 divided by R3 plus SC. So if I bring this one here, I will get 1 divided by R1. Okay. So V in divided by R1, that is equal to V naught SC plus VA into 2SC plus R1 plus R3 divided by R1 R3. Okay. So if I substitute this first equation and the second equation, okay, so I can write minus V naught SC minus V naught divided by SC R2 2SC. So if I multiply this one, I will get R1 R3 divided by R1 plus R3 plus R1 plus R3 divided by R1 R3. So if I multiply R1 on both sides, I will get, if I take minus V naught common, I will get SC R1 plus R1 SC R2 into 2 SC R1 R3 plus R1 plus R3 divided by R1 R3. So from this I can write V in by V naught is equal to minus SC R1 plus so if I multiply this R1 inside, or I can cancel this to R1, right? And I can write 2SC R1 R3 plus R1 plus R3 divided by SC R2 R3. So this I can write it as minus S square C square R1 R2 R3 plus 2SC R1 R3 plus R1 plus R3 divided by SC R2 R3. So you know that there is nothing but V naught of S divided by V in of S. So this is how we have to write. So minus SC R2 R3 divided by S square C square R1 R2 R3 plus 2SC R1 R3 plus R1 plus R3. So usually you can see, so if I divide the both side, multiply and divide by C square R1 R2 and R3. So I will get minus S divided by C R1 S square plus 2 S divided by C R2 plus R1 R3 divided by C square R1 R2 and R3. So this denominator and the numerator is in the format of AF alpha omega n S divided by S square plus alpha omega n plus omega n square. So this is a format for the my narrow band pass filter. So from this I can write, so if I equate these two equations 3 and 4, okay, so equating 3 and 4 I can write omega n square. So how this omega n square look like? Omega n square is nothing but R1 plus R3 divided by C square R1 R2 R3. So the omega n value is nothing but root of R1 R3 R1 plus R3 divided by 1 divided by C, I can take it common, R1, R3, divide by R1, R2, R3. Okay. So, we know that the alpha omega n is equal to, so if we equate, you will get into, sorry, 2 divided by CR square. So, my alpha value is nothing but 2 divided by CR square omega n. Okay. So, where the Q value is nothing but 1 divided by alpha. Okay. So, from this equation, from the numerator. So, what is the numerator? AF alpha omega n, that is equal to minus 1 divided by CR1. Okay. So, what is AF? AF is equal to minus 1 divided by CR1 alpha omega n. So, the alpha omega n, I can write it as 2 into CR2. So, AF is nothing but minus R2 divided by 2R1. Okay. Since resistance value will not be a negative, so I can write AF is equal to R2 divided by 2R1. Okay. So we have already solved this derivation. So they are given, so you can assume for this problem, can assume the C value is equal to 0.01 microfarad. This is the assumption. Okay. So first I want to find the value of, so they give given FR value, right? So the FR value is nothing but 1 kilohertz. 1 kilohertz, right? So the FR is 1 kilohertz and the A value is 10 and Q is 3. Q is 3. So from this one I can find the value of alpha. Alpha is nothing but 1 divided by 3. Okay. So we know that alpha formula is nothing but 2 divided by, so from this equation 2 divided by CR2 omega n. CR2 omega n. So I can write it as 2 divided by CR2 into 2 pi FR. Okay. So alpha value is 1 by 3. 2, the C value I have assumed as 0.1 microfarad into 2 into pi into 1 kilohertz, right? So if we solve, you will get the value of R. Okay. So we have find out the value of R2, right? So next, we know the formula for AF, right? So the AF is equal to R2 divided by 2R1. So from this I can find the value of R1. So the R2 value you have already found out. 2 into AF value is 10. Okay. So this is nothing but so from this I can find the value of R1, right? So next, I need to find the value of R3. So what is the value of F3? FR is nothing but so from this I can write the FR is equal to 1 divided by 2 pi C into root of R1 plus R3 divided by R1, R2, R3. So on solving, you will get the value of R3, right? So they are given omega n square is equal to R1 plus R3 divided by R1, R2, R3, C square. See, so this also I know, right? R1 value also I know, R1, R2 value also I know, C value also know. So from this I can find out the value of R3. Okay. So on solving, you will get the R2 value is equal to 95.5K and R1 value is equal to 4.7K. And from this, I can interchange the equation and I can find the value of R3 is equal to R1 divided by omega n square R2 R1 C square minus 1. Right. Uh, you can see the R1 value is 4.7K. And this I can write as 159 into 10 power minus 6 whole square, and R2 value is 95.5K, and this is 4.7K into 0.01 into 10 power minus 6 whole square minus 1. So if you solve, you will get the value of R3. So once you solve this equation, you can substitute in this formula, right? So this is nothing but C, right? 0.01 microfarad, and R1 is nothing but R1 is 4.7K, right? 4.7K, and R2 is 95.5K, and R3 value we are about to find. Okay. So once if you substitute in this equation, you can able to design the narrow band pass filter. Okay. So this is how you have to design. I hope this video is useful for you. Thanks.